Good afternoon, students. So today we'll discuss on the topic chemical kinetics. Chemical kinetics here, basically deals with the speed of the reaction. Um, so for a reaction, R, that is reactant, goes to the product. Then at the time t equals to 0, we can say that R equals to R0 and the amount of product is 0. Since R0 is the initial amount of the reactant, and when t equals to 0, that means the reaction has not yet started. Okay, so the amount of product is 0. Similarly, when t equals to t1, okay, t1 is greater than 0, okay, then R is supposed to, we'll just write R1 and P is P1. So similarly, it is when time equals to T2, we have to write here it is a R2 and here it is a P2. Now remember, the condition is that T2 is greater than T1. Okay, what will be the change in time? So delta T equals to T2 minus T1. And what will be the delta R, change in concentration of the reactant? So again it's a final minus initial, so it's a R2 minus R1. Similarly, the change in product equals to the final minus initial, P1, right? Okay, so remember what will happen here is R0 is the initial concentration, then as the time progresses the concentration will reach to the R1, that means the lesser concentration, lesser amount. Similarly the amount decreases as the time progresses to R2. So you have to understand that R0 is greater than R1 is greater than R2. Okay, so because as the time progresses the concentration decreases. Similarly, P2, okay, the amount, a concentration of the product P2 is greater than P1, because as the time progresses more number of product has been formed. Okay, the condition is, remember, T2 is greater than T1. Now we'll deal with the rate of a reaction. Okay, so rate of the reaction. For this reaction, R goes to P. So for this reaction, we say the rate of the reaction can be written as a rate of disappearance of, can be equals to rate, rate of disappearance, right? Disappearance of R, which is equals to rate of appearance, rate of appearance of P. Similarly, the rate of the reaction equals to, now rate of disappearance of R is the decrease in the concentration of R by time taken. It equals to rate of appearance of the P means increase in the concentration of product by time taken. Now decrease in the concentration of R, so it is a delta R by delta T. Now we have to understand the factor here, my negative. Okay, why negative? Because we know this delta R means R2 minus R1, and R2 minus R1 comes to be the negative value because we know R2 is lesser than R1. R2 is lesser than R1. Okay, so lesser value minus higher value gives a negative result, right? So this terms comes under negative. Now time is always positive because time taken. Okay, because time T2, delta T means T2 minus T1. Remember, T2 is always greater than T1. So overall this equation gives negative. Okay, but we know the rate of a reaction is always a positive quantity. To make this rate of a reaction positive value, we have to introduce here negative sign. Okay, and here the rate of increase in the concentration of product, so it is simply delta P by delta T. So this is the rate of a reaction. Here negative sign is not required because this delta difference delta P is obviously positive because it's P2 minus P1, and P2 is always greater than P1 because as the time progresses, right? Now coming to the unit of the rate of the reaction. Unit of the rate means you have to understand is the rate of a reaction. So here it's a concentration. Okay, concentration. So concentration is mole per liter divided by time is measured in terms of second. Therefore the unit of the rate of the reaction is mole per liter per second of rate. Okay, so unit of rate means unit of rate of the reaction is mole per liter per second. Now we will take one example. 2HI gives H2 plus I2. Okay, for this reaction we'll calculate the rate of a reaction. So rate means rate of a reactions equals to rate of disappearance of the reactant. So this is the reactant. So it's a minus delta HI by delta T. Now the 2 is here, so this factor will come as a 1 by 2, which is equal to, so there is no coefficient here, so simply we can write it's delta H2 by delta T equals to delta I2 concentration of I2, there is change in concentration. So this is the equation. So rate means rate of a reaction can be related as a negative half of change in concentration of HI by time taken equals to delta equals to rate of the production of H2. Okay, so its formula is delta H2 by delta T, which is equals to rate of production of I2. So there is delta I2 by delta T. We will take this example here. Example 4.2. It says the decomposition of N2O5 in CCl4 at temperature 318 Kelvin has been studied by the monitoring the concentration of N2O5 in the solution. Initially the initial concentration the concentration of N2O5 is 2.33 mole per liter, and after 184 minutes it is reduced to 2.08 mole per liter. The reaction is given like this. Okay, 2 of N2O5 gives 4 of NO2 plus O2. Now you have to calculate the average rate of the reaction in terms of hour, minutes and second, and you have to also calculate the rate of production of NO2. This is the equation in the question, right? So rate means rate of a reaction can be written as a this negative, right, minus 1 by 2 of rate of decomposition of N2O5 by time taken is delta T, which is equals to 1 by 4, right? The coefficient has to be in, this is the product, so 1 by 4 delta NO2 by delta T plus there is no coefficient, so simply will equals to delta O2 by delta T. Okay, so this is the equation. Now we'll use this portion only. Rate equals to minus 1 by 2 delta N2O5 by delta T. So equals to 1 by 2. So this is the final minus initial, we have already told. So the final concentration as per the book is given is 2.08 minus, and initial concentration is 2.33. Okay, and the total time taken during this process is 184 minutes. Okay, so this is minute and this is mole per liter. So after solving this equation, we are supposed to get this answer 6.79 into 10 to the power minus 4 mole per liter per minute. So this is the rate of a reaction. So we can also write it as the average rate of a reaction. Now we have to convert this per minute into different terms. So same equation, per minute means divided by minute. Okay, so minute, 1 minute equals to 1 minute, nothing means 1 minute means 60 seconds, so you just convert it into 60. Then after solving it, you will get some 1.13 10 to the power minus 5 mole per liter per second. For conversion to the hour, the next question is you have to convert in terms of hour also. So this is the equation we have already used. Now you have to convert this minute in terms of hour. So 1 minute means 1 by 60 hour, right? So 1 by 60, the 60 comes up here. Then after calculating, so you get this as a answer. Now the second part of the question is what is the rate of the production of NO2? That is the question, right? So what is the rate of the production? So this much is the rate of the production, right? So rate of the production of N2O5. So this rate equals to this. So you can say that rate is equals to 1 by 4 delta NO2 by delta T. So or the rate of the production of NO2 by delta T, so that is rate of the production of NO2 equals to 4 into rate. Therefore, now after substituting the value of rate that we have already calculated here, so we get the answer is 2.72 into 10 to the power minus 3 mole per liter per minute. Okay, thank you, student.